Hello friends, in today's session we are going to talk about the different methods that we use for the factorization of algebraic expressions. So now let's start with the first method, which is factorization using common factors. So in this method what we do is we first take each term of the expression and we find out the non-reducible factors of that term, of each term of the expression. So now when we write the expression again, we write each term of the expression as a product of its factors. Now after doing that, we now use the distributive property of multiplication over addition and subtraction, and we separate out all the common factors from all the terms. Now this gives us the final expression as the product of factors. Now we'll see what we've said with an example so that we can understand it, what we are trying to say. So let's first take the expression which we have to factorize. The expression is 24p square qr plus 18pq square r plus 9pqr square. So now we'll first take each term, the first term being 24p square qr, and we'll write it as a product of its factors. So if we see that 24 has factors 3 multiplied by 2 multiplied by 2 multiplied by 2, and then p square can be written as p multiplied by p, and then we write q and r. So that's how we write the first term as a product of its factors. Now we take the second term, which is 18pq square r. Now we write this term also in the similar way, and it becomes 3 into 3 into 2 into p into q and then multiply that with r. And now we take the third term, which is 9pqr square. So again write this term as a product of its factors, which makes it 3 into 3 into p into q and into r into r. So now we can see, looking at these terms which are now a product of their factors, we can see that 3 is a common factor in all of these terms when we write the term as a product of their factors. And we also see, if we look at 2 is present in the first term, it is present in the second term, but it is not present in the third term. So we cannot take 2 out as a common factor. Now if we look at p, we'll see that p is also present in all the 3 terms. So we can take p also as a common factor. We again see that q is another common factor in all the terms. We see q in all the terms. So we take q also out. And then similarly, r is another common term which is present in all the 3 terms. So we take out r also. So we take out 3 into p into q into r, which are the common factors in all the 3 terms. We take that out and we write the remaining part of each of these terms in the brackets. This is using the distributive property. So in the first term we are left with 2 multiplied by 2 multiplied by 2 multiplied by p. In the second term we are left with 3 multiplied by 2 multiplied by q. And in the last term we are left with a 3 into r. So now we can write this. Now since we were writing this as the product of factors, now we don't need to write it like that. When we do a final factorization, we can join them together. We can find one common product and then write them in the normal form. So the common factors which we've taken out have become 3pqr, and this 2 into 2 into 2 into p becomes 8p 3 into 2 into q becomes 6q, and 3 into r becomes 3r. So this expression 24p square qr plus 18pq square r plus 9pqr square can be written as 3pqr multiplied with 8p plus 6q plus 3r. And so we can say, looking at this notation of the expression, we can say that 3p, q and r are the factors of this term, and the expression 8p plus 6q plus 3r is also a factor of the given expression. Now let's take a look at the second method that we use for factorization of algebraic expressions. This method is called factorization using rearranging and grouping. Now, some expressions can be factorized by grouping the terms which have a common factor. Now in this case, what we do is we take the expression and we rearrange the terms so that we can find a common factor from the grouped terms and then take it out. Say for example, we have this expression to be factorized ax plus bx plus ay plus by. Now in this, we group the first two terms together and we take out x as the common factor from there, and it becomes x multiplied by a plus b. And the third and the fourth term we take together and we take y as the common factor, and we left with y multiplied by a plus b. And now we use the distributive property in that to make it x plus y into a plus b. So we can say that ax plus bx plus ay plus by can be written as x plus y multiplied by a plus b, and x plus y is one factor and a plus b is the other factor of the given expression. So now let's look at how do we actually do that in some other expression. Now terms of some expressions need to be rearranged. Now in the first example that we talked about, we did not have to rearrange the terms. The terms were already placed in the same order and we just grouped the first two terms and the last two terms together and took out a common factor. But in some of the expressions, the terms are not placed in that order, so that is where we need to rearrange the terms before we can do the grouping. So let's take an example. The expression is AB multiplied by x square plus y square plus xy multiplied by a square plus b square. Now we first open the bracket to get four separate terms. We get AB x square plus AB y square plus xy a square plus xy b square. Now instead of using, if we group the first two terms together, we will get what we already had in the original expression, but that is not helping us to factorize. So what we do here is we take the first term and we take the third term because they have a common factor ax, and we rearrange them, we bring them together, and we take the second term and the fourth term together. So we rearrange and then group them. After grouping them, we take the common factor out, which is ax in the first group. Ax is taken out and then we are left with bx plus ay, and in the second group we have by as the common factor with bx plus ay again remaining in the brackets. So now after doing this, we use the distributive property as we have discussed in the previous example, and we get the final factors like ax plus by into bx plus ay. So these are the two factors of the given expression. Now let's move on to the third method of factorization of algebraic expression. This method is called factorization by splitting the middle term. Now first thing to understand is this method is usually used in expression with three terms. We are saying usually, but that's not That does not say that this is the only place that we use it at. It is used at other places also. If it is used in conjunction with another method, then this may be used for expressions more than 3 terms also. So it is very important to understand that this is not the only usage, but we are saying usually that's where we use it. Now for expressions of the type ax square plus bx plus c, we split the term bx. See, the name of the method says factorization by splitting the middle term. So what we're trying to do here is, the middle term in this case is bx. We split the middle term bx into b1x and b2x in such a way that b1 plus b2 is equal to b, and b1 b2, that is the product of the two uh, splitting terms b1 and b2, becomes equal to the product of a and c. So let's see it with the help of an example. But the first thing that we do here is that we split the expression, and the expression now becomes ax square plus b1x plus b2x plus c. Now we group these terms. Once we've split the middle term, and we made the new expression, we group the terms in such a way that we get the common factors. This is where we use the first or the second method that we've already talked about. Now let's see what we're trying to say with the help of an example. Now we need to factorize x square plus 6x plus 8. Now looking at this, we are not able to find a common factor from these terms to factorize it directly. So what we do here is we split the term 6x into 2x and 4x. Now you can see that 2 plus 4, that is b1 plus b2, is equal to b, which is 6. So 2 plus 4 is equal to 6, and 2 multiplied by 4 is equal to 8, which is a multiplied by c, where a is 1 and c is 8. So we get 2 into 4 is equal to 8. Now 6x could have been broken up into 3x plus 3x also. But you will see that 3x plus 3x is giving you 6x, but 3 multiplied by 3 is not giving us 8. So it is not meeting the criteria that b1 plus b2 is equal to b, and b1 multiplied by b2 is equal to a into c. So that is why we have the only option of breaking it into 2x and 4x. Now we group the terms. We group the first two terms together, and we group the last two terms together. After grouping, we can take out x from the first group, and we can take out 4 from the second group, and we'll see x plus 2 is common amongst the two groups after factorization. So what we do now is again use the distributive property and make it x plus 4 multiplied by x plus 2. So we can say x square plus 6x plus 8 is equal to x plus 4 and multiplied by x plus 2, or in other ways x plus 4 and x plus 2 are the factors of the given expression. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.